Good morning, guys. We are going to work on multiplication today, not just multiplication with single digits. Most of my students should know by now they're single digits. 7 times 3, 4 times 7, 5 times 2, things like that. We're still working on committing to memory, but those things we should have a handle on already. What we're working on today is multiplication across double-digit or triple-digit numbers. So we're looking for 2 or more digits in each of these numbers. Such as our example we're using today, 43 times 37. That's going to be our example for both methods today. We're going to learn 2 different methods to multiply with double-digit numbers. The first one is called algorithm. Another word for algorithm, we could just call it old school or the standard way. Parents that are watching this is the way that we learned. When I was in school, it was the only way we learned. There's several ways now. We're going to talk about the algorithm method first, and then we're going to talk about something called partial product, which about half of our students enjoy using that method. Both methods work fine. We'll go through both of them step by step. Students, make sure you're taking notes. And at the end, we will have 2 problems that you have to do and have for me by Monday, right after Thanksgiving. All right. So we have 43 times 37. To use the standard algorithm, we're going to multiply the ones place from the bottom number, which is in this case is 7, by each digit in the top. So we're going to do 7 times 3, which is 21. We put the 1 there, and then we put the 2 up here. Because that's a 20, we need to put that in the tens place here. So now we're going to go from the 7, and we're going to multiply it by the 4. We're really not multiplying 7 times 4. It's 7 times 40. So 7 times 4, that's 28, and the 2 here. So we're going to put 30 here, but really it's 300. And we know that from our place value. So the 7 times 40, or 4, is 280. But when we do it with the standard algorithm, we can think of it as 7 times 4, which is 28. Then we have the 2 that we carried over to make it 30, or 301. That's the first step. Second step, this is where we lose some students here. We need to put a 0 underneath the first product. The first product is at 301. We need to put a 0 right underneath it. We call this holding our place value, holding our place. This means when we start multiplying the next number, that 3 and 37, that's not really a 3, that's a 30. So we're multiplying 30 times whatever number we have on top. Before we do that, we need to have that 0 there to remind us that we're using it as a 30 and not a 3. Once we have that, then we're free to just look at the number as just a 3. So now we'll do 3 times 3, and that we're getting into step 3 here. We're going to multiply the next digit on the bottom by each digit on top. So 3 times 3 is 9. 3 times 4 is 12. So we can put that just like this. Our fourth step, we need to add these products together. We have 301 and we have 1290. We need to add these together. 1 plus 0 is 1. 0 plus 9 gives us 9. 3 plus 2 gives us 5. Then we have the 1 right here in the thousands place. So the answer is 1,591. That is our answer for 43 times 37. And if you want to make sure you're close or that's a reasonable guess, we can use our estimation that we talked about last week. 43 can be rounded to 40. 37 can be rounded up to 40. So when we multiply these 2 together, we do our zeros trick with the zeros there. 4 times 4 is 16. So we get 1,600. And 1,600 is very close or very reasonable when we have 1,591 for our answer. That is how we do it the old school way, or the standard algorithm method. We're going to look at step 2 now, or the second method, which is our partial product. Second method is partial product, where we're going to be taking these numbers apart, and we're going to be getting partial answers, and at the end we'll add them all together. There's 3 main steps here. First step, we're going to create smaller problems. So we're going to look at that first number, that first digit in the ones place on the bottom, which is a 7 again, and we're going to look at the first one, 7 times 3. Now both of these are in the ones place, so we can just keep it 7 times 3. Then we're going to look next door. We're going to stay with the 7, but we're going to look at the 4 there. Now, once again, that's not a 4. It's in the tens place, so that represents 4 tens, or 40. And we'll put that right underneath our 7 times 3. Now we're going to look over here at the next digit for the 37 on the bottom. That 3 does not represent 3, but it really represents 30. So we're going to have 30 times 3. And finally, we're looking at that 30 again, and we're going to look up top where it's 40. So it's going to be 30 times 40. Now, if you notice the numbers here, they're either single digit, like 7 and 3, or they're a double digit number with a 0 on the end, like 40 and 30. When we have a 0 on the end, they are very easy to multiply compared to other numbers. So once you take the time to create these smaller problems, doing step 2 is not that difficult compared to the other method. So we're looking at performing partial multiplication now. 7 times 3, right here, is 21. And we're just going to answer these 4 problems that we presented. 7 times 40, we have our 0 that we can put right there. You remember with our multiplication with zeros, you can just, if the zero's on the end, you can just put it at the very end of your answer and then focus on the digits that are not 0. So we're putting the 0 here. We still have a 7 and a 4. 7 times 4 is 28. Next one, 30 times 3. We're going to put our 0 here. And then our 3 times 3 is 9. So we get 90. Then we have 30 times 40. Well, we're going to have 2 zeros here, one for the 30 and one for the 40. And then we have 3 times 4, which gives us 12. So that the answer to the last partial problem there is 1,200 or 1,200. So we have 4 partial products here. To get our final answer, we are going to look at all 4 of these and we're going to add them all together. Just like we did in the algorithm method, but instead of just 2 problems to solve or 2 products to add together, we have 4. And as you've seen, these were easier to get than the last one. So we have 1 plus a bunch of zeros gives us 1. 2 plus 8 gives us 10. Plus the 9 here is 19. So I'll put the 9 here, bring that 1 up here. Make that 9 a little better. There we go. All right, then we have 2, and 2 is 4, plus that little 1 up top. We have 5. And then we have the 1 hanging out in the thousands place still. So once again, our answer to the problem 37 times 43 is 1,591. Once again, some of my students like the partial product method because they can remember their zeros trick, and then they know their multiplication facts when you're just doing single-digit numbers, and it's easier for them. It makes sense for them. Others like the standard method. I want my students this week to try both methods this weekend. The first problem you're going to have is 25 times 13. 25 times 13. Second problem, you will have 132 times 21. Now, both of these problems, I want 2 answers for each. Each problem, you need to do the standard algorithm for and show me how that works. Second, you have to do partial product for both. So you'll have your partial product and your standard algorithm. They should be the same number. When you're doing number 1, you're doing standard algorithm and partial product. You should get the same answer, but I want you to show me both ways in terms of your work. When you come in Monday at 9:50 for our first day after Thanksgiving, you will have notes on this lesson, and you will also have these 2 problems done both ways. If you have any questions, please let me know by dojo or email. Have a good Thanksgiving.